Okay, it's merged.
Nice, thank you. It's merged in tutorials, Dylan?
Yeah. If you fetch, should see the lab one.
I don't see for some reason.
What?
As letting you both know, we'll start in 2 minutes. Okay.
Sounds good.
I mean, I don't see it either, but I mean, if you look at the PR, it
Yeah, I
should.
don't see it. I don't see it. I mean, you can just drop the command in the just drop the command in. It's weird.
Okay, pull origin. Okay. All
Is
right. Yeah.
everything good? Should I start letting people in?
Yeah,
Yeah.
go for it.
Perfect. Rishma, you can let everyone in now, then I'll speak.
Okay, perfect.
Thank you. Okay, so I can see that we have people joining in. Thank you everyone for joining. Welcome to the workshop with Arize. We'll be starting very shortly. But before we begin, I'd just like to give a few guidelines to make sure the workshop is smooth as well as engaging. So quick guidelines, please stay on mute unless you're asking a question to avoid background music. If you'd like to speak, just raise your hand and wait for Aman or Dylan to call on you before unmuting. You can also drop your questions in chat anytime. Our team will also be looking at the chat, and also Aman and Dylan as well. So since this is an interactive session, we encourage you to participate in discussions, but please be respectful and give others a chance to speak as well. If possible, keep your cameras on. If not, that's also okay, but it would just make the workshop more engaging. Another thing, the session is recorded, and we'll be sharing the recording and the resources afterwards as well. Finally, we ask everyone that to participate courteously and respectfully so we can create a more positive experience for everyone. And that's all. Thank you. Aman, you can take over.
Awesome. Thank you so much. All right, good to see you all here. Well, let's hop right in and yeah, super excited to share a little bit around agents and building smarter agents faster. So thanks to Data Science Dojo for inviting us to kind of share more here. So I'll hop right in and just do a quick intro of ourselves. So my name's Aman. I'm on the product team at a company called Arize. Dylan, do you want to give a quick intro of yourself as well?
Yeah, absolutely. So my name is Dylan Kuzon. I do community and developer relations at Arise. So very nice to meet everyone.
Yeah, awesome. So we're going to be hopping in and giving a bit of an overview of how to build agents. This is a pretty lengthy workshop. It's around 3 hours, but we're going to try and break it up, make it kind of fun, interactive, and leave a good amount of time for questions as well. So just by way of a little bit of background, so actually, I have a technical background myself. I actually started my career as an engineer working on evaluations for self-driving cars, and then went over to Spotify and worked on the machine learning platform there, which is how I discovered the company I'm at now, which is called Arize. We're an evals and observability company. If you haven't heard of us before, we're sort of one of the leading observability and eval companies in the space. We're backed by Microsoft and Datadog. And we actually have companies like Spotify, Uber, Reddit, Instacart, DoorDash, and 150 plus more customers. So we've been kind of lucky to see and learn a lot about how these customers of ours are actually building and deploying agents in the wild. So, if this workshop is really going to be sort of a deeper dive into some of those lessons of how to actually build agents from 0 to 1. We'll use some off-the-shelf frameworks just to get us all oriented and started, so we can get kind of get our agents up and running right away. And this workshop is really built for people that are trying to learn, maybe you're building agents or you want to learn more about core concepts like RAG, tool calling, MCP, and evals from a more practical lens and hands-on lens. And finally, you'll actually be able to walk away from this workshop with an end-to-end example that you can deploy in your own company. It's really going to be kind of a starter pack example. Think about it that way. But hopefully this gives you a little bit of a hands-on into some of these more kind of specific advanced concepts. A couple of quick questions. Usually I run this workshop in person. It'd be great if you could just drop in the chat, where you're calling in from. And just to while you kind of put that message in there, I myself, I'm in New York right now. Dylan is in New York too, but feel free to engage in the chat, drop in where you're calling in from. That'd be great. And while we do that, as you introduce yourself, I'll just reiterate some of the ground rules here that the Data Science Dojo folks kind of mentioned. We're gonna basically, the format of this is going to be a little bit of, we're gonna do some slides per each of these sections, and then we're gonna have a hands-on workshop for basically a lab component for each of the sections here. The lab is going to be in Python. So I sent out a survey before just to check if everyone is comfortable with Python and how comfortable you are. Don't worry, it's going to be pretty starter, like very kind of, pretty beginner friendly Python code. And we're going to pause at each of the lab sections and make breakout rooms so that people can, work through the coding portion live, and we'll be there to help you if you get stuck with debugging or if you run into any issues. If you still can't get the code working for any particular reason, I just ask that, so that we can kind of keep the workshop moving, just feel free to flag and come back to the code afterwards as well if you need to. This is all going to be public GitHub code, so you can always come back and reference it, and we'll be dropping links so that you can catch up at any point as well. Awesome. Wow, this is a really diverse group. We have people from Orange County, Nashville, Sweden, Texas, Boston, so pretty awesome here. And then, yeah, if at any point you do have a question, feel free to raise your hand, and I'll try to leave some space for questions, space naturally throughout the workshop. But if it is a burning question, feel free to raise your hand, and you can always ask the question in the chat as well, and either myself or Dylan will be able to take the question live as well. So try to ask the question in chat first. If you feel like it's really important or urgent, raise your hand and I'll call on you and you can go off mute, just so that we can kind of keep the workshop going. So a little bit of just like framing of what your team might look like. So these are kind of the two main personas that we're sort of seeing building AI agents and actually responsible for evals and sort of the nitty-gritty of actually getting their agents off the ground. We have technical users in our platform, so think of that as like AI engineers, developers, data scientists, but we're actually seeing more and more subject matter experts and AI PMs. Just again, as sort of like a quick question for folks here, where would you say you fall into one of these categories? Are you an AI engineer, developer, curious about AI, but not really fully writing AI code? Or are you an AI PM or another type of persona as well? Maybe just drop in the chat here just so we know how many folks are kind of split across different roles. Oh, wow. Nice. We have a good number of AI PMs hopping in. Full stack transfer. Nice. Cool. Okay. Awesome. Well, you all are in the right place. We have a lot of folks here thinking about, sort of AI PM at a higher level, which is awesome. So it's actually a good starting point here for, where we kind of see ourselves fit into the landscape This is something that a lot of teams experience firsthand, right? Like building prototypes is easy, but getting to production is hard. But what do we really mean by that when you're thinking about, AI code or AI in products? Really fundamentally, like how do you integrate AI into your product? So starting with a prototype, this might be your like lovable bolt replit type of prototype, or maybe you're just getting started with something like LangChain or Crew AI or one of the agent frameworks. There's really a series of steps you have to go through to get to a point where you feel more confident deploying your application. And our goal is really to help guide you through a few of these steps and show you why you need to do things like curating data, looking at your data, writing evals, and really ultimately getting started with being able to understand what your agent is actually doing so that you can go back to your team and say, hey, this is the things we need to change about our agent before we actually go and deploy to production. So we're going to do a quick overview, introduction to agents. We'll finally answer that question you've probably heard a million times. What is an agent? We're going to get into agent engineering. What does that mean? How does that apply to a skill that you might want to start learning or learning more about or picking up in this job environment? Then we'll start getting into agent frameworks and architectures. And with that, we'll kind of talk about the core components that go into agents, agent frameworks, and architectures, and then talk about RAG, evaluation, and finally getting to production. Just because this is a lot of time and it's a lot of topics, I'm going to do my best to cover each of these, but a couple of the sections we might go a little bit faster in, and depending on how much time we have, I want to leave a good amount of time, about 30 minutes at the end, for any questions. So, we'll try to get through as much of this as we can, but if we don't cover some of the slide material, just know that that's something you can always come back to at the end as well. Okay, module 1, let's hop right in. Before we actually talk about agents, another quick question for folks here, since we have a mix of people, AI PMs, leadership role, developers, and full stack developers learning about AI. How many folks have actually built an agent? And if you have built an agent, in what framework did you build the agent? Maybe please drop that in the chat too, and would love to just sort of use that as a starting point for where folks are at in terms of building agents and where you maybe have gotten started already. LangGraph, great. Okay, we're going to be using more LangGraph in this presentation too. So just to sort of zoom out for a sec while folks kind of put that information in. When we think about agents, there's really, three main components here that we like to talk about, which are the input, which is usually the query or the thing we're asking the agent to do. There's the output or the response from this agent-based system. And then in between that is really what we think about from an LLM-based application. And an agent is really a mix of these components. It's really the LLM with code around the LLM call that helps with constructing the prompt, the context, the things the agent has access to, and where it gets data to ultimately be able to solve a user's question or perform a task or perform, actually accomplish what the user is asking for. So we define agents as software-based systems that can take actions on behalf of a user utilizing reasoning. That reasoning is powered by AI, and specifically in this case, these days it's a lot of LLMs. That agent may also be able to decide and determine what next action to take using routing. So that can be determining, which tool to call, where to query data from, or what next action to take. And then last but not least, that agent can actually take action, and that is making API calls, constructing requests to external services to actually pull in data, and actually take action on the data. Diogo will be covering MCP a little bit later in this one. Stick around for that. So a couple, just to kind of orient us a little bit around agent use cases, these are probably things you're going to be familiar with. If you've used, the Comet browser from Perplexity or Operator from OpenAI, you're probably familiar with things like desktop or browser agents. If you've built automations using N8N or another no-code, low-code system, you've probably built something like a personal assistant. A lot of people are using Claude Code. That's another example of a type of agent, or cursor agent for coding. What we're going to be covering in this presentation is actually going to be a research assistant. So this is actually going to help us pull data, do planning, querying, and actually take action on the data that we pull. And we're actually going to go ahead and build one of these from scratch ourselves. There's a lot of resources out there on some of the most popular agent frameworks, including LangGraph, Llama Index, and Crew AI. I urge you to take a look at some of this supporting material from Deep Learning AI. Fun fact, we actually also have a course with Deep Learning AI around evaluating AI agents, where some of this material is actually covered in that course as well. So if you want to go deeper or you have a desire to learn more about evaluating AI agents, feel free to check that out as well. It's really good sort of condensed content to give you an overview of different agent frameworks and then how to evaluate AI agents as well. So let's take an example of an anatomy of an agent really quick. So we're going to be using this example of a trip planning bot. It's sort of a toy example, but it actually covers a lot of the components here that sort of standard agent services and products actually have today. So it's a pretty good example because it actually covers a lot of the like nitty gritty, the how of how agents work. So let's take an example of an AI agent, and the task I'm giving this AI agent is to book me a trip to San Francisco. So what does that agent need to do? It needs to actually go in, figure out which tool to call. It needs to call the right APIs, construct the requests to those APIs. It needs to pull down the context from those requests and the responses from those APIs, construct a response and actually make it something that we can use downstream. And then overall, it needs to actually perform the task and generate the right answer, right? So there's a lot of steps in an agent that, seem really simple at a high level, but it's also sort of the steps that you can think about a human taking when you ask a human, hey, go and book me a trip to San Francisco. Well, each of these steps you can actually break down further and figure out, was the right action taken per step? So for instance, figuring out which tool to call, you can determine, was that the right tool to be selected? Search, did we construct the right API call? Did we use the context correctly? Did we construct the right response? So each step can be broken down into further subtasks that you can actually evaluate in the same way that you can evaluate a human doing the same task. And the thing is, that means that there's a lot of ways that agents can go wrong. That means that, things like calling the wrong tool, constructing the search incorrectly, generating a response that maybe isn't super friendly or inappropriate. Any one of those things going wrong can result in an unhappy user. And an unhappy user means a poor business outcome, which means your agent isn't doing the thing you want it to do. So it's really important to think about agents as, systems that can do all of these really amazing things, but just because they can do these things doesn't mean they're doing them correctly. And that's a little bit of what we're going to dive deeper on as well. So remember here, this is just the reality of agent engineering. When you change your prompt, you change your model, or you change something even really small, like adding a single line to your prompt or to your code, that can mean that your system can break. And so that's what a lot of agent engineering that we're going to be covering is actually going to talk about as well. The reason for that is because this is kind of a new way of developing products. In the software testing sort of deterministic world, sorry, these should be switched, but software is deterministic. LLM agents are non-deterministic, right? These are probabilistic stochastic systems. That means that given the same inputs, the LLM can produce different outputs. LLM agents can take multiple paths, whereas unit tests or software code are deterministic, right? So like when you think about end to end, the software itself is deterministic. The unit tests 1 + 1 = 2 every single time. In agent world, try this out yourself. Ask ChatGPT, what does 1 + 1 equal? You tell it it's wrong. Say go back and recalculate it. It's going to take 30 seconds, and it might land up with a different answer. And we know that because of all of the tokens that we have to generate here. The last but not least, and really maybe the most important point here, is that improving agents relies on your data. And so a lot of what we're going to be covering is actually how to get data out of our agent so we can actually use that data to improve on the agent itself. So it's actually building a data flywheel from the output of the agents that we can use to improve on the agent. Whereas traditional software testing relies on integration tests on your existing code base. Okay, with that, we're going to jump into our first lab, and we're going to get started by actually running an agent on our local machine. So let me go ahead and drop this link in the chat. And this is the GitHub repo with a README. As Dylan said here, for the labs, make sure you've got a code editor ready with the CLI and Python 3, and ideally Git so that you can pull the GitHub repo down. If you can't, for some reason, if you don't have Git in your command line, you can also just kind of show you here on my machine as well. You can go back up to the parent repo, and you can also just download as a zip if you don't have Git in your command line for any particular reason. So you can download the folder as a zip. And then what you want to do is navigate to Python LLM agents, agent mastery course. And what we're going to do is actually start with just the README, which has the code example in there of what we want you to run. So this is actually going to just set up a LangGraph system on your local machine, and you're going to host it yourself. So if you're using VS Code, a terminal, using Cursor, any of those will work for this. And what you're going to do is actually, what you will need is an OpenAI key. If you have an OpenAI key, if you do not have an OpenAI key, please drop in the chat and we'll be able to help you out. We'll message you separately, but let's assume that everyone has an OpenAI key. And if you don't, please drop in the chat and we'll help you out. And we'll come back to the Arize space ID for a sec. But what you're going to do is navigate to this folder, CD backend, and you're going to go ahead and install the requirements. And then once you have those requirements installed, you'll just start the agent up. And I'm actually going to stop sharing screen, and I'm going to share my entire window and go through these steps in real time as well, so we can do this together. So I have the folder here. Let me open a fresh terminal. So I'm going to go and just navigate to CD, which is how you get to the right directory, which is Python. CD agents, agent mastery course. And I'm going to go to the backend. And I'm just going to go ahead and install this. And I do also recommend using a virtual environment for this. So I'm going to copy that command here. Let me activate that virtual environment. And then we UV install, which is just going to install the requirements for the system. Sorry, we're going to go off there. And as always, if you have any questions, just feel free to drop it or raise your hand if you're stuck or have any questions on any of this so far. Okay, let's see what's going on here.
You forgot to source the environment.
Oh, whoops. I copied it into...
Oh, no, it's here.
Yeah. Okay, it looks like there's an issue with FastUUID. This is the live demo part. Okay, this was working right before, so...
Yeah, I think you might be able to remove light LLM for requirements. We're not.
Okay, let's do that.
Them.
Okay, sorry about that. So I think if you're hitting this, just remove light LLM from your requirements. I think that didn't make it into our... Let's try that now. Okay, that should work. Yeah, good call. Dylan, maybe feel free to push up a quick change to remove that as well from the requirements, if you have a sec. Okay, and then we're going to go ahead and actually start this agent. I'm going to go back up, copy this command.
Do you want to show how to set up the environment variables?
Yeah, good idea. Nobody steal my API keys or my keys, please. So I'm going to copy. This is my .env example. And yeah, good call, because this is missing my API keys. So let's go ahead and copy this environment.example, and we're just going to rename it and provide my OpenAI key. Let me just share this really quick. So all you have to do is basically take this .env.example. We'll come back to the Arize setup in just a sec, but let's just get the agent working first, and then just rename this to .env. And you should have your env set up. Let's try that again. Okay, so it says that, sorry, are you running into anything, Diogo?
Yes, is the API from OpenAI so short, the DM apostrophe D? Is that right?
Sorry, I don't know if I follow the question there, Diogo.
Okay, Dylan shared with us the API key, but but what is really strange is that there are only three characters. The little short, is that right?
Dylan, I don't know if the whole key was, maybe we didn't copy paste over the whole key to
Yeah, that's all. I'll just share it in
Oh, okay.
Yeah.
Thank you.
We're going to revoke the key after this workshop, so feel free to do as much damage as you want for the next couple hours here in the meantime. Okay, so if you are at this stage where in your terminal you see this AI trip planner, you're in the right spot. If you aren't at this stage yet, please drop in the chat. I'm going to pause here for a couple of minutes for folks to keep getting set up here while we help them kind of run the agent locally.
Yeah, I'm having trouble to set up the environment, so I'm not yet there. So
Okay, we'll give it about 5 more minutes, and if you have a question, please drop in the chat, and we can help DM you or pull you aside to a breakout room to help debug if you're running into issues.
So I want that environment file. If you can help me with that.
With which part? Sorry, Giri.
That environment file that we created.
Yeah.
Did you ping me that APIs?
It's
Keys?
in the chat. It's in the chat.
Okay.
Ranga, this is just Cursor. So this is an IDE that you can download. If you don't have Cursor installed, let me go ahead and share a way for you to get Cursor installed. Do you have any type of IDE or terminal?
No.
Okay.
I use Cursor.
Yeah, you can use any IDE for this one.
So we have to download onto the local?
That's right. Yeah.
Oh, I need to type this file, open API key and all. Oh, I have to.
So what you need to do is copy paste the API key into this this line over here.
Yeah,
OpenAI.
this line I have to type.
You can copy paste it from the chat. It should look like this basically.
This line is not there. Yeah.
And then rename .env. You know, it shouldn't say example. It should just be .env.
You ran the Python for the requirements of TXT, you did Python -R. and then when the requirements.txt.
Exactly, yeah. So just to show the commands again, let me zoom in here.
OpenAI API key, okay.
So you're gonna hit Python 3. So I'll copy this again, just start to finish. So you can just copy these commands basically. It's in the README as well for the tutorial.
So once you set the environment, so you set the keys, right? That's it, right?
That's right, exactly. Sorry, Zoom is really annoying where it takes up the whole window, and I'm just trying to show where.
Oh, you don't need to set up the Arize key now, right? Arize space side.
Not yet. We'll do that in the next portion in about 10 minutes.
And you go to the agent mastery course. From there, you created the source and then virtual environment.
Yep, exactly.
Okay.
I'll kind of show where to do that again as well. And sorry, Gary, I'm gonna mute you, but if you have questions, just drop them in the chat, and then we'll help you get started. And
sure.
And then Dylan, feel free to, if you want to make a breakout room with Pushpak, and maybe even Gary, you guys can might be a good way to help debug a couple people at the same time.
Yep.
And run.
Yeah.
So after setting the environment, you just run the agent, and where should we run the agent from?
The same terminal. You can
Okay.
run it in the same terminal. Yeah. So let me go ahead and just copy paste the same commands again as well, just so that we have them all in here. So all you got to do is navigate to this URL. This is the URL. That's the README in that URL, basically. And then you're going to navigate to you're going to get your Python 3 and virtual environment set up. You'll cd backend. So you're going to go to the backend folder, pip install. Oh, sorry, you need to in source. By the way, I will say this is probably the hardest part of the demo. The rest of it should be pretty easy once you get set up here. So I know it takes a little bit of while to get this part set up, but then once you're good, then we'll be able to go through the rest of it pretty quickly.
So what did you run to run the agent? What did you do? Sorry.
Yeah. So so to run the agent, you go back to basically do this and type this. So this will be from the root of the directory. It's just that command, ./start.sh. Okay, so I'm going to go ahead and push forward here. We're going to run that again. And I'm going to navigate to, let me go ahead and share my entire screen. So you should be in Cursor or in your IDE environment. And you should have at this point run the start command. And once you have that started, you can actually just go to the UI that it says. This is where the UI is running. It's on the same port. And you should be able to see this plan your perfect trip UI on your local machine. maybe drop in the chat if you're at this point, and if you are not at this point, also feel free to drop in the chat so we can just do a quick check-in at the 30-minute mark. Okay, nice. Woo. We got one person there. Anyone else? Okay. Elvis, maybe join the breakout room. If we could get Elvis in the breakout room, Dylan should be able to help you out there.
How do I join breakout room?
Data Science Dojo folks. Yeah.
Yeah, I've added him.
Okay.
Please
I
go.
think Rakesh and Elvis would be 2 folks to join the breakout room. Nathan, do you want to share what error you got? Maybe I can help debug you right now.
Yeah, I can share quickly.
I don't think you'll be able to share screen, but maybe just let us know what error you got.
Oh, when I run the script, it says some process, spawn process -1 error.
You need to put your OpenAI API key in .env. This is the OpenAI API key, and rename the file to .env in the backend folder.
It says no model named land graph. That's what it says.
Did you install the requirements?
Yeah, I did.
You pip installed requirements in the shell?
Oh, in the shell? Oh,
Yeah.
okay.
So I've dropped and copy pasted all the commands you need. I'll paste them again for you here. You should just be able to run them one by one in the folder. So it's creating a virtual environment, sourcing that virtual environment, going to the backend folder, installing requirements.txt, going back up one directory, and then starting the agent after you've put in the env file or the env API key. Anyone else running into any issues, or anyone else here at this point? Feel free to drop in the chat. I see Namrata's here. I got Diego here. Diogo, is it Diogo or Diego?
It's Diogo.
Diogo, okay. Anyone else? We've got about 16 other folks where I have no idea where you are in the process, so. Give it about 30 seconds more, and then we're going to move on. Okay, nice, Sherwood. Thank you. Okay, I'm going to go ahead and close the breakout room so those folks can come back. And then we'll keep pushing on. Pushbach, did you get it working? No luck?
Mine
Yeah.
is working. After that, my
Yep.
pushback is back.
Did you folks get it working or no?
Yes,
It's
it's
working.
working. The environment is set up.
Installation is done. The environment is set. Yeah.
Okay, perfect. Awesome.
Mine is working, Aman. I'm fine.
Yours is working as well. Awesome. We're moving. We're humming along. I know it's just annoying to do the environment setup stuff, but it's a one-time deal, and the rest of it gets easier. I'm just waiting for the folks from the breakout room to come back, and then we'll keep pushing ahead here. And don't worry, there will be more time if you get stuck at all. So, you know, not the only session for a part of the breakout room for us to stop. So, but let's go ahead and push on a little bit more here. So now that we've run the agent, you should be at this. Okay, yeah, go ahead, Pranav.
Okay, I
Yeah,
think
sorry,
we have
one
not
question.
yet run the agent. I mean, we were stuck at the environment setup issue, right? And then we went into the breakout room. Is there anything that we missed out, or?
Did you set up your environment correctly, or did you?
Yeah. Now
Okay.
it is set up here.
Okay, all you have to do is basically run these commands. So once you've set up your environment, then go back up to the root of the agent mastery course and run .start.sh ./start.sh, and that should run your agent.
We're not seeing the right screen, Aman.
From the agent mastery course. Okay.
Yeah, exactly. I dropped it in the chat. What the commands are.
Man, sorry to cut you off, but you're showing the slide deck screen and not the code screen.
Yeah. Right.
Yeah. It's just the same commands, and I just put them in Zoom as well, just so that in the Zoom chat, so we can just use them all as the. I'll go ahead and run it one more time, just so we're all.
Yeah, my agent is running now. Yeah.
Okay, so this is basically it. So I'm in the agent mastery course root folder, and I run .start.sh, and you should see this screen. And then what you can do is actually open this link in your web browser. And now you should see this agent.
Can you go back to the command prompt once again?
Yeah, it's all in the Zoom chat. So if you need to, you can just look in the Zoom chat.
Okay.
Yeah, everything, all of the commands are in the Zoom chat. They're also in the README, so it's the same commands in both places. So just kind of follow along with which step you're at in the Zoom chat.
I think it's open.
Awesome.
Yep.
Awesome. Okay. So hopefully you have the OpenAI key in your .env. You've installed your requirements. You've installed your requirements in your local, in your Python virtual environment. And now you should hopefully start the agent and see this UI. So if you're on this screen, congrats. You have now run an agent on your local machine. Let's go ahead and test it. So we're going to go ahead and actually just type in initial command here of saying we're going to Kyoto for 5 days and let the agent plan the trip for me. At Sherwood, you can just follow the commands in the Zoom chat. So you can run it from the back end as well. It's a different command, or you can just go back up one directory, to the root and click this. This command will run everything for you in the root of the I think it's because you can technically run the back end separately from the front end, but we're just doing a convenience command. And good call. Yeah, so it says start from one level up. Okay, so let's take a look at this. So we have our trip, which is destination Kyoto, duration 5 days, and budget. And we have this output here. It's a little dry to me. It doesn't really like scream a great
Can we put some SFR?
Sorry, go ahead, Giri. And if we could just use the raise hand just so we're.
Oh, sorry.
Yeah, go ahead. Do you have a
Can we
question?
use a different city for this, or
Yeah, you can use any city you want. Try to put anything you want in there. And I mean, this is like a machine. This is an agent you're running on your machine. We're going to jump into how it works in a sec. But try out different cities, try out different duration, try out different budgets, interests. But congrats, if you're on this screen, you have now run a LangGraph agent on your local machine with a UI and a backend fully functional that you can use for all sorts of things if you wanted to build your own custom agents in the future. So this should be a good starting point for us to hop into what agent engineering is. Okay, so hopping ahead a little bit here, and don't worry, we're going to come back. If you still have problems running anything, in about 10 minutes, we'll help you debug. Agent engineering. So what is agent engineering? Well, we define it as the job for, basically designing what the ideal user experience should look like for your product, assuming that there's AI in the product. And I think that there's a lot of misconception of like, let's just put AI into everything now. Like you're probably in your companies or businesses, you're coming up on, what is it, Q3 now? So what happens in Q3? We start going into Q4, and Q4 is company planning, right? We're going to start planning for next year. So most likely, you've probably heard this discussion come up, which is maybe your VP has come up to you or to your team and said, hey, what's our strategy for next year, right? We're going at 2026. And as we all know, 2025 was the year of agents. Everyone was saying 2025, we're going to have agents everywhere. We have hundreds of agents. Well, where are all of the agents? A big reason why we don't see a lot of agents in production just yet is because it's really, really hard to develop agent products in a way that actually works to delight and make the user experience actually very good. And the things that you need to think about when designing your agent are what context does the agent need? What tools does it have access to? Should the agent be in the foreground or the background? Let's take an example. So we just built this trip planner, and there's a couple of boxes on the left-hand side here that you're putting information into. But the planner itself is actually just a few steps. It's the same parts of the agent that we talked about before. There's a system prompt or a prompt. And so it's really just a prompt that says, like, help me plan this trip. The agent can do things like planning or reasoning. That's an optional step that we're going to decide whether or not to use with the agent. It has tool calls. So it can actually do things like take information for research, for itineraries, for your budget, for local experiences. It does RAG, so it can actually take the destination information and do a lookup and find out, hey, let's find more information about this destination, about Kyoto, about different places. And then all of that basically goes into an LLM. And that LLM call effectively generates an output. It generates the itinerary that you saw on the right-hand side. So really what we're trying to do is think about each part of our, each part of our product has components to it. So when we think about agent engineering, think about how we want to construct these components to ultimately get us to the itinerary that we want. Because again, we're doing this as a trip planner, but in your world, you could make this agent anything else you wanted. It could help be a finance agent or a budget planner agent. It could help you write code for the front end of your AI, of your application. It could help you do SQL, like natural language to SQL. But you're still going to have to go through these steps of thinking, what are the parts of my agent to get to the output that I want? That's basically what agent engineering is. It's context engineering plus tool calls plus LLMs to get you to an end system. This is another way to look at that, which is you have your agent tools. What are the tools that the agent has access to? Can it look up information from the internet? Can it look up information from a database? That all becomes context. And how is that context constructed? What does the prompt look like? What is the data going into the prompt? All of that goes to an LLM, and then it generates an output, generates code. So there's really a couple of parts of the system here, the system prompt, reasoning, tool calling, RAG, LLM. These are all opportunities to iterate on and change your agent in some way. So I like to think of these as like product first principles for trip planning or a trip planning agent, or really any agent. And you get to decide which components you want to use and not use. It's all Python code. And of course, it's modifiable depending on what you want the agent to do. So that kind of brings us into, well, I'm kind of drawing all of this stuff as like whiteboard diagrams so that we get like a visual representation. But the way that people actually do this in production is they set up their agent with observability. And observability is essentially the way for you to look at this black box, right? Like when you think about it, I have my code running. I'm just typing in stuff and the code runs and my backend is running. I have my website, which is just a UI layer. And I can like type things in there and I can see, okay, the agent is generating an itinerary. But how does it actually work? What's going on underneath the hood to make those system calls that we saw from the the whiteboard diagrams back here. How do we know that this is actually what the agent looks like? That's what observability helps you out with. It turns this black box of an LLM and the surrounding code from the LLM into a way for you to debug the system and basically identify what steps is the agent taking, what are the tools being called, is the agent hallucinating, and ultimately gives you transparency to be able to see and share with the rest of your team. Here's what we want to go and fix. Here's what the agent is doing. And you can all start speaking the same language. I'll give you an example. I love this diagram. If you've never seen this before, it's a bunch of scientists, or I think it's a bunch of blind people, or like, people wearing bandanas, and they're looking at this elephant and they're looking at it from different angles, right? And depending on where you're sitting on the part of the stack, this is like any product team, any engineering team, right? And someone comes to you and says, hey, our agent is crashing. It's not performing well. Well, you're going to get like 10 different answers for why. This actually happened yesterday. Anthropic put out a blog post where they said, hey, we've actually had performance degradations with Claude since August. And we had 3 different bugs and we couldn't figure out what was going on. And it was because the agent was really complex, blah, blah, blah. But if you go on Reddit, if you go on X, people are complaining that Claude was like hallucinating more. It wasn't performing well. The reason for that is because you had a bunch of teams looking at a pretty complex system, but from different perspectives. And so nobody could speak the same language for, hey, we have an issue. What's going on, right? So you're looking at it from your own lens, your own perspective, and you're not seeing the big picture. Well, the reason that that's valuable is because now you can speak this language of converting what your agent's processes look like into what's called spans and traces, which are terminology in observability. And so now you can go back to your team and say, hey, this is the span that has an issue. This is the exact interaction that I want to go and fix. And it doesn't matter whether you're an engineer or a PM or someone else on the team. This is the common language that AI engineers and agent engineers are actually starting to speak. It's really, here's the log, here's the trace, here's the example we want to go and fix. So now you can all work on the same thing. And that's a really, really powerful component of actually building production-grade AI systems. So let's take this for example here. Observability basically allows you to make changes to your system and actually verify that those changes took place. So for example, you can change the architecture of the agent. You can change your prompt. You can change your model. You can change the context going into your agent. And whenever you make any of those changes, you can make sure that those changes took effect. Exactly, Sherwood. These are now integrating with OpenTelemetry. Exactly. We're going to talk more about evals a little bit later here, but evals are basically the system on top of your traces that allow you to kind of programmatically check whether something was good or bad. But before you even start grading, before you start doing evals, you need observability to start speaking that same language. So another example I like to use for traces and spans is think about a trace as the end-to-end action that you want the agent to take. So in our case, in the trip planner, the agent is taking the inputs from the user and generating an itinerary. That end-to-end interaction, that's represented by something called a trace. It's the complete route that the agent is taking to solve a problem. What happens actually though, when think about it as like delivering a package, right? Well, you got to do all of these steps in between. You have to pick up the package, got to get directions, get on the street. All of those steps, you can think of those steps as spans or individual actions, individual sub-processes that the agent needs to take to actually get to that final end state of a successful package delivery. So we look at this as traces and spans. We're going to mostly focus on traces and spans. A couple other components of observability are metrics, which are things like latency, P99, if you've heard of that term before. But that's basically how long is it taking for the agent to run. These are metrics, things you'd look at the system level. And then logs, which are for each part of each span, what are the events being called? We're not going to focus too much on logs in this one. We're going to mostly focus on traces and spans. Really important here. A good mental map for what a span is it's basically just a JSON. It's a JSON in a row. And we're going to look at those more closely, but I just want people to know it's really just text. It's a string that is basically constructed when you hit construct an itinerary for me, and it breaks that up into multiple fields in that JSON. And that's it. It's just a row. It's a row with the JSON. Each trace is comprised of spans, so we're going to look at this in more detail. And the spans can be of different types, different kinds. So you can have prompts or LLM spans, tooled spans, reasoning or agent spans. So the type of the span can be different. And that's a really important step. So you have trace at the top level. You have spans, which are the individual steps to get to that trace. And each of those spans can be a different kind or a different type, like get directions, database query, etc. This is really what that looks like practically. You basically see this represented as a tree, where the top level object is the trace, and the sub objects or the sub rows underneath that are called spans. And how these spans ladder up and work is basically a representation of your code, of your agent. So the most important thing to take away here is agents are represented by traces and spans, and we're going to dive deeper into what those spans are. Quick example of what that looks like. You can actually have what's called a session, which is multiple back and forths with an agent, and that's going to have multiple traces. And you can see here that the trace data or the span is kind of just a JSON object on the right-hand side. Sherwood had a great question, which was like, is this OTel? This is basically OTel. Exactly right. OTel is short for what's called, it's called open telemetry. And open telemetry is basically just a protocol for being able to log span data and trace data in a standardized way. It's basically the leading protocol for observability. It's being adopted, it's been adopted into like every system you've probably used in the last 5 years, most likely has open telemetry underneath it. So it's a standard for any application, not just AI applications. What we've kind of contributed back to the space is open inference, which is another package on top of open telemetry that uses the same open telemetry standard, but it contributes extra information that you can log through instrumentation. And the reason that that's really powerful is because traditional telemetry and traditional logs and traces, they don't know about LLMs, right? Like we invented this protocol years ago. It's open source, but it doesn't have any knowledge of what LLM should look like. It doesn't know about spans. It doesn't know about agents. So what we've done is we've kind of put out this package here called Open Inference, which is also open source. Dylan, if you don't mind, would you mind grabbing the GitHub repo for Open Inference and just dropping it in the chat as a resource for people to access? And Open Inference is also open source. So it's basically a standard that all of those companies I mentioned earlier, Reddit, Uber, Instacart, Duolingo, DoorDash, and 150 plus others, they're all using Open Inference, which is this open source package, to basically take their telemetry data, and you can think of it as like move some columns around and adjust the same data to be formatted correctly for LLMs. That's all it is. It's basically the same data, just with some columns and rows moved around so that you get LLM, basically purpose-built for agents, essentially. The last part of this is instrumentation, and that's really just the way that you get the spans and traces set up correctly. And that's just the action that you take to hook into your framework, hook into your LLM calls, so that you can actually get these logs. And we're actually going to set that up for our systems. I'm going to take a quick pause here and answer a couple questions. You could have directly got this from the LLM model, why we use vector. You don't have to use vector. We can remove the vector database as well. We'll talk a little bit about why we used it, but all of this is totally flexible, the framework. Do you see eBPF eventually finding its way into the observability for AI agents? I know that OTel is considering as the fourth pillar of observability. These are events, something protobuf or something like that, I think. Right, Sherwood? This is like using events as opposed to just spans.
Well, it gets you accessibility as to what's happening on the OS.
Okay.
So you can actually capture information metrics from what's happening in the OS. So like if you were to take, like if you're doing a neural network and you said, hey, I'm just going to parse through this huge array. But then if you vectorize it, you can see a huge difference. eBPF will show you an enormous difference in why one runs so much faster than the other.
Okay.
Just curious if you're looking into that to, hey, why is this agent running slow? Maybe it's something that I'm doing in my code, and eBPF could tell me that.
Interesting. I'm not super familiar with that, but I can tell you that's really interesting. I'll take a look into that. I actually haven't heard of that before. So thanks for sharing. I love learning something new. So I'll take a look into that after this. What I can say is that what I want to kind of underscore on this slide and like the concept of observability is, look, whether or not you use whatever provider you end up using for observability, my recommendation for when you're building agents in your own company is standardize around OTel, standardize around the open source standards. Because as Sherwood is alluding to, is the space is so early that things are going to change. But what you want is that your platform is going to change along with those standards so that when the standards get adopted, your platform doesn't break. So that's the reason that you want to use kind of open source standards. And we're always going to be built on top of OTel, so you don't have to worry about that. But in general, whichever standard that you want to use, whichever platform you want to use, whichever frameworks you want to use, matters less, I would say, than picking the right open source standard to build on top of. I'm going to take a look at eBPF. I know that there's changes that are going to come down the line from OTel, but we will be first to adopt them as well. Okay, that actually brings us up into setting up observability for our agents. This is a step where you want to navigate to lab number 2, and I'm going to go ahead and share that on my screen. And we're going to look at the README for lab number 2. And this is going to be setting up observability for our system. So let me go ahead and open this up on the right-hand side. By the way, a fun fact, if you want to read Markdown in Cursor and IDE, just open preview, and it gives you like a Markdown native rendering of the text, which is kind of nice. So what we're going to do is we're going to set up Shri will send I'll send a, this is, let me just send you the quick, the repo that you need to copy paste on your end. And feel free to message Dylan as well. He'll be able to help you out as a facilitator if you get stuck. So, so kind of pushing ahead here. Yes, each tool does have its own spans, and we're going to see what that looks like. So prerequisite for this one, you should have run your agent. It should be running, and the UI should be running. The next thing we're going to do is we're actually going to sign up for an Arize account. And we're going to add these 2 pieces of information to our .env file. That's all we're going to do, basically. And then we're going to rerun the agent, and then we'll go back to Arize. So what I'm going to do is I'm actually going to go to the Arize system, share my whole screen here. And I'm going to sign up. Oh, not this one. This one. And I'm going to go to app.arize.com. And let's just go ahead and sign up for a new account. Oh yeah, thanks, Dylan. That's the URL you want to go to. So feel free to follow along as I do this. You should get an email. And if you don't worry if this is moving a little too fast, I'll also pause for about 5 minutes after I do all of these steps to have folks actually kind of follow along as well. So I'm going to set up a password. Okay, so once you're on this screen, you can hit start tracing. That's what we're going to do. We're going to start with tracing. We've already actually done most of these steps already. The main thing that we're going to try to do is actually go to this button, create or manage your API key. If you're not on this screen, don't worry. You can always just go to the settings tab. It's just going to take you there anyway. And that will actually take you to this page. So let me do that again so I can exit this. If you're on Arize and you see this, you go to settings. And it should take you to the API key page. Then we're going to hit new API key. And we're going to name it. I'm going to call it agent. Once you hit the key, it's the same as creating a key from OpenAI. You're just going to copy that, and it's going to copy it to your clipboard. And then I'm going to go back here to cursor. I'm going to go back to my IDE. And I'm going to go to the .env file that we had before. This is the same place that we put our API key. Let's go ahead and put the API key in here. So I just copy paste it in the Arize API key. Once I've done that, I'm going to copy the space ID. That tells us where we're going to log data. So basically with these two pieces of information, we have tracing set up within this repo already, and our data is going to go to the right place. It's going to go to my account to the right space. Once you have that set up in your repo in the .env, I'm just going to go ahead and kill this process, the one that I had running before, the same agent. And I have to restart it. So I'm just going to hit the same button to start the agent up. Okay, it says it's start up. I'm going to go back here. And now I'm going to type in the same request that I had before. Yeah, exactly. Control-C or Command-C to kill the process. So I'm going to go ahead and type in the same thing. Kyoto, 5 days, moderate. And I'm just, actually, let's change it. Let's make it Tokyo this time. Tokyo is a cool city. Okay, and then we got this itinerary here.
I'm yet to go there, but it's saying no API key is found, or in the settings section, the current space ID is mentioned.
You have to create a new API key, Pushpa.
Okay.
Yeah. So once you create a new API key, this is what it looks like. So I'll just create another one just to have it. And you can copy it and put that into your .env. Save your .env file, Command S or Control S, and then restart your localhost. Then you should have this agent, kind of running here, and you're just going to send it another request. Let's say you want to go to Tokyo, wherever you want to go. But now you're going to notice something, ideally, if this works, and there's no guarantee it will, but let's see if it does. So let's go ahead and try that again. Tokyo, 5 days.
You may want to reset your terminal to apply the changes in the environment file.
Yeah. Good call. Dylan, do you have the commands for that? Maybe we can just drop that in there really quick.
Yeah.
Thanks. Good call. So we're just going to source that same virtual environment. I always forget to do that whenever I run this.
Yeah, I usually kill the terminal.
Yeah, so you can kill it, open a new terminal, and then you need to source, what is it, Python?
It's source.venv/bin/activate.
Is it this? Sorry, I think you have the. I'm just copy. Yeah. Source.bin.activates. Oops. Do this. Oh.
You're being feedback.
Mm-hmm. So that's a really good point Dylan brought up, which is you have to kill the terminal and then go back to the backend folder, and then you can run this command, and it will pull in the latest environment variables, which you'll need. Now, when I do this, I should be able to run my I'll go back here and run the agent. So I'll copy paste this back in. Thanks, Dylan. So steps to follow are restart your terminal, navigate back, let's try this again. Something's not working.
Where do you get the space ID?
The space ID is in this page, the settings page. It's the this thing here.
Thank
you. Yeah. Okay. This should have worked. Isn't that working? Dylan, any idea why this might not be working?
I'm testing on my end, so you see.
This was working before. This is the live demo part, so always love that. Give it a sec here and see what's happening. That's in there. It says my Arize tracing is set up. Ah, thank you. Is it possible that the light LLM instrumentation was required?
I don't believe so.
Okay. Let's try to figure out what's going on. Sorry, y'all. We're hitting a little bit of technical difficulty. We'll be back in just a couple minutes once we get this up and running.
Okay, since Aman and Dylan are solving it, we can take a short break. You guys can get snacks or water or anything for some time. Okay.
Good call. Thank you. Yeah, I'm like, wow, that's yes, please please do that. We'll be back in about 5 minutes. We'll get this working. It was working right before, so it's probably just a temporary bug. So we'll be right back in a couple minutes.
Perfect.
You want to say like 5 minutes or so?
Yeah, should be good.
All right. See you all in a little bit. Okay, I'm back if other folks are as well. And I got it working. I think I figured out what's going on. And if you're running into this as well, let me give you a set of commands to try to fix it. So what I had to do, I think it has something to do with this virtual environment setup, but basically, let me just drop in the commands that I ran. It's actually closer to what we did in the README. So if you run into any issues, basically just follow this. I'm going to copy paste that in just a sec. Okay. Basically, just do this. If this works, this works for me. That I just tested this out myself. So it is basically restart your terminal, go back to the backend folder, reinstall the requirements if you need to, and go back and awesome, Pierre. Glad to hear it. And then hit start.sh.
I did not run that in requirements.txt, Aman, but the UI got launched.
Oh, great. Awesome. Good. You only need to, oh yeah, you can skip the requirements if you've already installed them. Just some folks joined later. In case you haven't installed. This is just like start to finish, basically, getting it going. Okay, awesome. I'm glad to hear that people got this working. So we're going to hop into showing that in the UI. So once you've run a single request, let me go ahead and do this again. Let's say I'm going to Spain for 5 days. It's a bit of a short trip, but for the purposes of this demo, we're going to go ahead and run that query. I need to restart it actually first because I killed it. Try this again. We're going to do Spain, 5 days, plan my trip. And all right, we've got this itinerary here. Once I go back, I should actually see this as my page. And I'll see a project here called AI Trip Planner. Okay, looks like it's running a little bit late. It's 15 minutes. Okay. Oh, this is the one from Tokyo, but let's go ahead and take a look at it just for the purposes of this while we wait for the Spain one. And once you click into a single row on the request, you should see basically what we showed in the slides earlier, which is your trace tree. And this is essentially the execution of your agent from start to finish. And what you can do is actually open up this agent graph. And once you click on that, this is actually what the agent looks like. This is basically a top level agent, which then sends a request from the user into 3 sub-agents, the budget node, the local node, and the research node. And then all 3 of those go into an itinerary, and that's what you see on the other end. So now when we're looking at this, we're actually seeing how our agent is working end to end, which is pretty cool. I mean, I think from looking at, from going from a black box like code to being able to see the agent actually showing up in real time, that's basically the power of observability. On the left-hand side, you're actually seeing your trace at the top level. And then each individual row is basically the spans. Let's take a look at one of these spans just to understand this better. You can see here that there's a prompt that says you are a concise travel agent. Respond with 200 characters or less, outline the lodging, meals, etc. And it actually does the travel plan here in a very brief sort of way. I can go in further and actually look at the itinerary, and you can see create an itinerary for Tokyo. Awesome. What's kind of cool is that I'm going to show one more thing here, and then I'm going to hop back for folks here. But you can actually replay the entire agent an entire span end to end as well. So that last span that I clicked on had a prompt in it. And this is what the prompt is, which is create a duration for this destination and travel style. And each of these are basically variables. Those variables are what we got from the front end, actually, Tokyo 5 days moderate. And that's actually what's going into our prompt. And you can see that here. That means that I can replay the system by making changes to my itinerary prompt. For instance, I can say, always respond in a super upbeat tone and use emojis. Maybe for some reason this thing isn't responding in the way that I want it to sound for my company, right? This agent. And then I can do this A/B test and actually compare what this looks like. Oh, I need to enter an API key. Let me go ahead and do that really quick. Please hold while I enter an API key. No, Sherwood, actually, the agent has tracing set up in it already, actually, right off the bat. So as long as you just start, as long as you've put your Arize API key and space ID, you should be able to see what we're seeing here. Diogo, what is the issue that you're running into?
I think that it's because that I didn't feel the integrations I'm doing now.
Okay, got it. Yep, you got to put in your Arize API key and space ID for this step. This is the main part, basically. And you can see here I can now A/B test. So I have this prompt playground and I have a very different itinerary. It looks like it uses a lot more emojis. It's still not super upbeat, but it's a little bit better than it was before, where it's just kind of monotone, basically. And it says, hey, hope you have an amazing time exploring Tokyo on this 5-day itinerary. And what's cool is it's, again, the same agent, the same template, but now we can change the template in the platform and actually see A/B test what the output from the agent looks like. Really powerful to do that all in one place. I'm going to pause here before we get deeper into agent frameworks. How are people doing on this so far? Were you able to get your trace to appear in Arize? And if not, please also drop that in the chat so we can just sort of benchmark where people are at.
The traces work for me, Aman, but this playground, the exact prompt did not come as per this one.
The reason for that is because you might need to be on the right span. And don't worry, we'll come back to the playground in just a sec. Mostly just wanted to demo what the playground looked like, but we'll come back to it in a little bit. Basically, if you go into the playground, this is the Spain itinerary we put in before. You go down to the itinerary node and click on this span. And then if you click on view and prompt playground, it should carry over the variables for you here.
Okay.
It's basically that last span in the list, which has the itinerary.
Cool.
When I go to the projects page, it shows the steps to execute to get my telemetry data. Sherwood, you might need to go back and restart your terminal once you have the .env file set up with Arize space ID and API key. So I might recommend that. Were you able to restart your terminal with that, with those two?
Yeah, I'll try that, see what happens.
Okay, cool. Yeah, basically it's just getting the environment variables to stick. Okay, we've got a couple people that are stuck.
Once you restart, sorry, Aman, once you restart, just go onto the Arize app and just refresh it.
That's right. You should run the agent with another request. So we'll go ahead and run that again now. So instead of Tokyo, let's say we want to go to, I don't know, I'm running out of cities now, San Francisco. Try that out. And you see here an output. And then if you go back to Arize in your project page, oh, you know what? I did a slight thing that might slow me down here, but that will show up over here as well.
So we have to go to the projects page.
Yeah, you go to projects and you should see the project here, the latest project. And if you don't see it here, just double check that you have the right API keys in place. Okay, so feel free to drop, just say either yes or no if you have traces showing up in the chat. You can just put in yes or no, and I'll be able to interpret that. No, okay. Not yet. Diogo, were you able to restart your terminal with the API keys in?
Okay, we'll try that.
Yeah. Elvis, how about yourself? Were you able to put the API key into .env and restart the terminal?
No, I'm still trying to finish up my configuration from my previous step there. It's a corporate laptop, so it's pretty well locked down.
Oh, okay.
I set up a virtual and trying to work through that. So I'm a bit behind, but I'll catch up.
Okay. If you have issues with Arize or with networking, just drop that in the chat. You might need to, because if you're using a corporate laptop, you might need to go with the open source product, which I'm going to drop a link for in here as well.
Okay, gotcha. I was able to get to the site, created the account, got the API key generated.
Okay.
So I'm good on that side. What's supposed to be the Arize space ID, by the way? I got the key, but what's the space ID supposed to be?
Yeah, so if you go into settings, you should see the space ID right here, and you
Okay,
can just
perfect.
yeah.
Mhm.
No worries. We're trying to make it easier to use, so it should get easier as time goes on.
Sounds good.
So what you can do is actually, you can actually just go to the playground from here as well. But if you wanted to load up with the same itinerary span, you navigate down to the bottom here, and you can just click on the span and click on this button here, View and Prompt Playground. It's in the top right of the page. You click that button, and it will take you over to here. And then if you wanted to do
not working
that, the button's not working?
Yeah, like it's not taking me to this prompt playground.
Interesting. You're clicking the button, but it's not opening the page?
Yeah, nothing is happening.
Are you seeing the span and all of the other information?
Yeah, I can see everything.
Could you try a different LLM span and see if that works? You can try a different orange span. Yeah. Try this one maybe. And click that View and Prompt Playground.
No, it's not working.
Okay, that's interesting. I haven't seen that one happen before. And then you can A/B test with duplicate prompt here, basically.
No. It's actually, it took time, the other one.
Okay, internet. And then if you hit, someone asked, how do I A/B test? You just hit duplicate prompt. And now you can rewrite the prompt and say, always respond in a happy way or in a certain way. Okay. Let me check if we got the breakout room going and how folks are doing there. Give it a couple more minutes here. Cha-ching, bada bing. I like that. That's good to hear. Sorry, I'm in New York, so I extra kind of put a little bit of emphasis on that one.
Is there a breakout room open?
There is, yeah. There is a breakout room if you're running into issues. Data Science Dojo.
Yes, who wants to be in the breakout room? Can you tell me in chat? I'll add you quickly.
Yeah, this is Nitin. Yeah, please add.
Okay, then I'm adding you.
And I'm just checking in with Dylan how that's going.
So for Playground, do we need to integrate with the OpenAI?
Yes, you do. You do. Yeah, Diogo also needs a breakout room, Data Science Dojo. So the thing with the OpenAI thing is like you can use any playground model that you want to. So you basically go to settings, integrations, and you can add any model you might have access to. If most people have access to OpenAI, you can just put that in here and just put the same API key in here. And I'll recopy the one that we sent if you need to run that again.
I use the same API.
Yeah, you can use the same one and it'll work. So
Can you carry it one more time? How do we get into that place?
yeah, so it's the settings
Settings. Okay. Okay.
and integrations,
Thank
and then
you.
OpenAI. Yeah. Okay, and so Sherwood, what we offer is a open. So there's two answers actually to your question. You can host Arize on premise at your company, and we're actually hosted on premise and in a bunch of companies, large enterprises. It's not a problem for us at all. If you wanted to self-host or have your own open source version of Arize, this is sort of a smaller kind of package version, but you can look at Phoenix. A lot of teams are using the open source version if they want to self-host it. So it just depends where you work.
Okay, thank you. Very nice.
Awesome. And this will just keep getting easier to use. I know it's a little bit of pain the first time around. We were just, we were getting the labs all set up right before. So a couple of steps we missed, but, once you get started with a real project, it's really just a couple lines of code and the data starts to show up. So, okay. And there was a good question. I see DSPy support. Yeah, you can. You can get prompts generated by DSPy as well. So we actually have a couple different ways to do that. If you're using DSPy, you can trace DSPy. So I'll go and show that really quick. Arize DSPy. We have integrations with DSPy. And I will share this in the chat. And you can also optimize prompts in the Arize platform. So we have a mechanism for you to actually create a task and optimize the prompt as well. And I'm going to go ahead and close the breakout room. Now we're getting into the fun stuff.
Hey, Aman, can I ask you a real quick question?
Yeah, go ahead.
So let's say that I have inside my agent, I've got code, and I start a trace and I create spans inside my own code. Will they get integrated into that so they'll actually show so that I don't have a break of seeing two different traces?
100%, 100%. So each of these we kind of covered a little bit of this in the instrumentation part, but we basically offer auto-instrumentation, which is what we're using for purposes of this presentation and workshop. But everything in your code, if you go back to your code and you look at the main.py, one sec, let me pull that up for us really quick. Main.py. You can wrap any of your tool calls, you can wrap any of your functions in decorators. And what's awesome is when you use this decorator, your code, when it's instrumented, when you import the package for instrumentation, we'll just slurp up all of the right function calls and everything as individual spans. And that's what shows up here. So it's all through a combination of auto or manual instrumentation. So you don't have to use frameworks. You can use your own code, and it will show up here as well.
Fantastic.
What's cool about this is I'm going to show one more pretty cool feature while we wait for the folks. Okay, actually, it looks like they're done. So I'm going to close the breakout room. And I'm going to show one more thing here, which is you can actually ask questions. You don't have to just look at this data, right? Like this is kind of a lot to process. I've got my graph here. I have all of my spans, but I can also open up Alyx, which is our co-pilot. Think of it as like Cursor for AI engineering. And I can say, what's going on here? And Alyx will actually work like it is an agent that we built ourselves that will go in and actually do analysis on the individual spans in the trace and pull out insights that we can then use for iteration on our agent. This one doesn't have any issues with it, so it's kind of boring because it's just going to tell us the same thing. It's just like, here's what's going on with the agent. But it does say, okay, implement context consolidation so that there's, the context could be improved or managed better. And give some suggestions for things I can improve on with my. So that's a little bit of setting up your agent with traces and observability. An example of us iterating on an individual span, and then actually having Alyx tell us and do analysis on our spans and on our agent. You can imagine that this type of agentic way of working means that we can use our agent to actually improve on our, use the Arize agent to actually improve on our agent and have these two agents sort of like talking to each other to improve. And that's sort of what the end goal is for where we're headed. Okay, so with that, we're going to hop ahead a little bit more. And just going to get this open. Give me one sec here. Okay. Okay, so now we're going to hop into agent architectures and frameworks. And we're going to use this as a bit of a way to segue into evals as we get further along. So agent architectures are basically tell us how to build a reliable and scalable agent. And some of the foundational patterns here that we see are reasoning, which you kind of saw in Alyx. You saw reasoning as well from how we are setting up our agent in the first place. There's like a top-level agent that decides what to use. That agent can take actions, and then there's the interaction of how to manage that context and state. Here's a few examples of common types of architectures that we tend to see when we think about agent-based systems. So we have here, routing, orchestrator worker, parallelized agents, which is the example we're using in our sort of demo, an example with the trip planner, and then evaluator optimizer. So a router is typically used when you have distinct categories that benefit from separate handling and when classification can be done reliably. So for example, a customer support bot is a really classic example of a router where you have, essentially a router agent that can specialize where to actually send a query or request. For instance, you might have different specialized agents for refunds or processing frustrated customers or asking about policies. And so the router can say, hey, based on this user's request, let's take an example. Give me a refund for my flight. This router agent can say, oh, let me go look up and use the specialized refund agent, which has access to tools to look at docs about refund policy. And it has access to tools to actually process the user's information and give them a refund. It's a lot like calling a call center. Think about it as literally calling a call center and saying like, press 1 for refunds, press 2 for billing. that's what a router agent architecture looks like. In the case of an orchestrator, this is useful when subtasks can't be predicted ahead of time. So this is an example of when we don't actually know what the user's question is going to be. And you might need to call multiple agents at the same time, and sometimes those agents may even need to call each other. An example of this would be something like a coding agent, where you might want to modify multiple files while also doing things like searching the code base to get more context and information. So the orchestrator can actually kick out to multiple agents, and those agents can go and perform tasks like searching over the code base, editing a file, saving, running tests. And the single orchestrator's job is to say, let me write this Python file or write this, add this feature. So the difference here is really, why are we going through different agent architectures? Just to sort of zoom out for a sec. The reason is because how you design your agent ultimately determines what your observability, evals, and iteration is going to look like. So you're kind of deciding your agent strategy based on the architecture itself. Here's just a few of the architectures that we see, but it's helpful to think about how these pieces come together when you're designing your agent system. Then we have parallelization. And this is useful for when you're trying to split a task up across multiple agents. For instance, you can split like in this case, we're actually assigning, it's a little bit like the router agent, except that we're calling multiple agents to solve the task of generating an itinerary, because there's different parts of an itinerary, right? Like there's the budget, there's the weather, there's the local research. And we want each agent to do a specialized job to go and do that research and come back with information that then the itinerary can kind of pull all of it together to generate that final output as an aggregated way. So it's really helpful to basically have each agent be specialized, sub-agent be specialized here. And then those results are aggregated so that you're not putting everything into one LLM call or one agent to go and generate the itinerary. That job is split up across multiple agents. So it's kind of more specialization as well. Okay, and then last but not least, we have an evaluator optimizer agent. This one is really cool because you're actually using the output from your agent or LLM call, and you're evaluating that and using that evaluation to improve on the agent in the first place. And so this agent can sort of work in a loop and keep improving on its response to get you something that you actually are happy with in the end. So for example, if I copy paste our presentation into OpenAI, into ChatGPT, and I say, translate this into Spanish, I'm okay for that agent to take more time. And we've seen this with ChatGPT, right? Like now with reasoning, it generates outputs, it might go back and regenerate output, go back. And that's because it's actually running, there's a sense of evaluation of each output to keep iterating or refining the output until the evaluator is happy with the end result. So it's actually helping you kind of it's not exactly reinforcement learning because there's no verifiable reward, but it's sort of a system that uses evals, which we're going to talk more about, to ultimately get you a good output at the end of the day. Yeah, go ahead, Pranav.
So the pattern of like a sequential agent, where there's one agent that creates an output, passes to the next one, and so on. Is it considered just like a normal chain of an agent, or is it considered a separate architecture pattern, which is like a sequential one?
Yeah, that's a good point. We didn't put that in here, but normally we do call that a sequential agent. So that's a really good point. We just call that a sequential agent, which is if it's a multi-agent system, you can have agents calling in series as opposed to parallel. Good question. Yeah. Great question. So this is mostly, I would say that these agent frameworks, these agent architectures are really to give people ideas for what type of task you are trying to solve in your company or your product, and how that can map to existing design paradigms for agent systems. I also highly recommend, there's a few great blog posts that I'm going to go ahead and pull up now because they're that good, that Anthropic has designed around agent best practices. And I think these are all great, and they're worth looking at, like when to use sub-agents, how to build effective agents. And I'm going to go ahead and share that in the chat so that people have access to these afterwards as well. These are 3 pretty good blog posts on agent architectures that kind of cover some of this in more depth as well. So we're really just giving you a high level here. Aside from the architectures, there's actually different frameworks for agents. For instance, you've probably heard of some of these terms before, like Crew AI, Mastra, AutoGen, Agno, LangGraph, which we're using here. Each of them has slight specialties that you might want to go to one for versus another. But really just kind of know that this is kind of a good reference, maybe a good screenshot to take of why you might want to pick one agent framework versus another. The best part about using an observability platform like Arize is that we are agnostic to any framework or language that you're using. We work with all of these frameworks and all of these languages, so you can still get observability and evaluation. Why that's helpful is because you might want to change your system from Crew AI to Mastra because it's changed slightly, or you want to have multiple agents running with multiple frameworks. And that's totally supported in Arize as well. So we're actually going to skip this lab. Actually, let me take a look at it really quick and see if we have some time to go through it, because we are coming up a little bit short on time. So I just want to double check how long this one is to run. Actually, we can go ahead and run this one. This one's a pretty good one to run. There's one small change you're going to need to make to this lab. So this lab is a Jupyter notebook or Python notebook, which you should also be able to run in your IDE. So all you have to do is navigate to lab 3. You click on that, and you should see this on the right-hand side. And you'll need to select a kernel. I'm going to go ahead and say, pick a Python environment. Just pick this one. And now we can actually run through this lab. In this lab, we're actually basically going to be comparing these different agent architectures to each other and looking at what they look like in Arize so that we can evaluate which one we want to pick. So here I need to actually put in my Arize space ID and API key again. So I'm going to go ahead and hit install. And we'll need to go back to Arize here to get that information. So I'm going to go to my settings page, create a new API key, copy that. And when I hit run, you'll see that you'll see basically me get prompted here for my space ID or API key. So let's go ahead and grab that information. So the space ID is in the settings page. I'm just going to copy that. And then I enter it at the top of the page. You'll see that here. Let me go ahead and paste that in. And then I'm going to be prompted for my API key, which I just put here. Copy paste that. And here I'm going to, okay, oh, awesome. Nice. This is set up correctly. So I'm going to go ahead and actually just run this. Oh, I need to pip install. I always forget to do that.
So if you select the virtual environment that you just created, you shouldn't need to do a pip install.
Yeah, I just always forget to do that. And I don't know if I have that stored here in my kernel.
I just pasted that comment in the chat.
Oh, thank you. Yeah. We should for sure put this in the notebooks too, because I always forget. People are using different environments. Thanks, Dylan. So we're going to go ahead and install that into our virtual environment. Okay. Then we're going to hit run here. And what we're basically doing, just to explain step by step, is in this notebook, a notebook is basically a way for you to run Python code in sort of a sequential way. So it's really just like the same thing as what we were doing before with the agent, but sub parts of it. So it's, instead of hosting it as a server, we're actually just running parts of the code in Python. And what I'm doing is I'm setting up my Arize tracing in the notebook itself. And what's really cool is like we can actually just set up that tracing to run for the parts of the agent. Yeah, so Sherwood, this is a bit of just an example. It's kind of a side quest. So that you need to run the tracer provider in the notebook because this is its own. You're setting it up for this project that we're about to run in the notebook, basically. And then I can go ahead and set up the same local host. Yeah, so this one is it's a little bit different than what we're running for what we ran just before with the trip planner. It's the same code, it's just parts of it instead. And we're going to set up the test scenarios here. So we have a trip to Tokyo, a trip to Paris, and this is just data that we're going to use to run through the system. So let's compare the current parallel architecture here. So I'm going to go ahead and hit this run button, and it's actually going to go ahead and send those same 3 requests that we have here, Tokyo, Paris, and Bangkok. And it's going to make a request to my server, and you can see that it's actually hitting the server here, plan trip. And it's sending those requests to the server to actually make itineraries. Okay, it looks like it ran. Let's go ahead and look at our data in Arize. Oh, I might be on. Actually, let me do one more thing really quick. I'm going to go back to I'm just switching accounts because of an issue I was having earlier. So I'm just going to go ahead and just do that setup one more time. Yep, thank you. So I'm actually just going to go through the steps one more time. So if you haven't done this yet, you're in a good spot since we'll be going through it one more time. Okay, let's try to run this again. Go back here. Okay, I might be still having some issues with my Jupyter notebook, but maybe you all are doing okay. It just might just be me that's running into this for networking reasons. Yeah, I think I'm just having some networking problems. Dylan, any chance you have it up on your machine running?
No, but give me a second.
Okay. Yeah, I think I'm running into some issues with my account. Just just receiving requests, I think. Let me try one more thing really quick and see if that works. I'm gonna go ahead and create a new virtual environment. Try this one more time. And if this doesn't work, we'll just kind of move ahead. Could you drop in the chat for folks here? Yep, we'll send out the recording afterwards as well, Rakesh. Feel free to drop in the chat if you got the notebook working or you're still waiting for or you're stuck at a different step. Stuck on the beginning of the notebook. What's the issue you're running into, Diogo?
I tried to run that on the Jupyter notebook that is on the command line, but some let me show the problem.
I don't know if you'll be able to share screen.
I know. Aman, isn't better to break room in this case?
Oh yeah. Good call. Yeah, let's do a breakout room. If you want to hop in with Dylan,
please.
We can do another breakout room. To our Data Science Dojo friends, if you are here. Thank you. Thanks, Dylan, for being the breakout room guy. Appreciate it. I'm gonna keep chugging along here and we'll come back. Maybe we'll try again in 5 minutes, come back and we'll kind of push ahead. Okay, I think we have a couple folks that want to get added to the breakout room. Cool. Thank you. Okay. And in the meantime, I'm gonna try and figure out what's going on here. I think I'm just having some networking issues where Notebook isn't sending the data to my Arize instance. Yeah, weird. Gonna have to try to debug this later. Okay, in the meantime, we're gonna hop back to, we'll start getting ready for the tools and MCP section. So we're moving ahead in a couple minutes here. Feel free to drop in the chat, Jupyter Notebook working? And we'll give it a couple minutes here and then we'll hop into the next section. In the meantime, while that that group is sort of working through their notebook and installation, I'm going to show one more part of the product here, which is what we talked about earlier was actually being able to replay parts of your agent graph. And the thing is that single example, that A/B test, like that's cool, but it's not really a data-driven approach to see, okay, am I making like a sustained change to my platform or to my agent? What we want to do there is actually create a data set, the concept of a data set. And this data set is basically a way for us to essentially replay more data. So I can create think of it as like rows of spans that we've curated that we can use for proper sort of A/B tests over multiple rows of data. So remember, you have a trace, which is the sort of the main part of the tree, like the main the top part of your trace tree. You have the spans, which are the individual rows. Think of those as like rows in a spreadsheet. And then I have a data set here, which can be contained by multiple spans or multiple rows of data. So I can create that data set, and let's go ahead back to here. And you can also just upload a CSV if you want to use for testing, just create data set. But I go into the data set, and I can, from here, actually, let's say we want to add multiple rows. Let me go ahead and add like 2 or 3 different rows. So I'm going to add this one. I'm going to add to my data set. And I'm just basically going in and adding itinerary spans because I want to create a data set of itinerary spans. So feel free to follow along here, and we will use this data set for some testing in just a moment. So I've got 3 or 4 different examples here, and I can go ahead and go into this data set. And what's great is from here, I can go ahead and run an experiment from the data set. So if I hit create in Playground, it's actually going to pull over that same data set. So let me go ahead and do one more thing. I do need to save this as a prompt because that doesn't get pulled over automatically. And I'm going to go ahead and hit save and save itinerary prompt 1. Save as a V1 itinerary. And I can pull in that same data set I just created. And now when I look at this, I have multiple rows or multiple examples that I can use to replay the same data and the same information. So it's really handy for me to, let's say I want to do an A/B test on more than just one row of data. I can now do an A/B test on multiple rows of data on a single data set object. So I can do the same thing here and say, make sure the itinerary is friendly and always uses emojis. On top of that, I can add what's called an evaluator, and this is the LLM as a judge eval. And I can add an example here for a friendly eval. So for example, in here, I'm going to hop ahead a little bit and copy paste a template that we're going to come back to in a sec. But I'm basically going to add a prompt template for evaluation. And this is an LLM as a judge. So you've probably heard of LLM as a judge before, but it's one of the tools that we can use as evals to actually check the output of the system in the first place. So in here, I have basically 2 labels, friendly or robotic. And I'm going to go ahead and put that in here and say, this is what we want to check for. Are you sounding friendly or are you sounding robotic? And what's interesting is I can actually edit what the definition of friendly or robotic sound like. So I could say friendly is defined as upbeat, cheerful, while robotic is something that sounds like an AI generated it. I can also say friendly should require emojis, because maybe that's just what my brand really wants to gravitate towards. It's like you should always use emojis with our customers or something like that. And I can go ahead and create that eval. Now when I do this, I run this test. Let's go ahead and change the model as well. And we're going to go ahead and use GPT 4.1, and we're going to compare it to the original model and prompt. And now I'm going to hit run all. And you can see that I'm doing this A/B test again. Yeah, let me go ahead and share that. It's here. One second. And you can just copy paste that into the evals part of the prompt playground. And now we actually have this eval running on the outputs here. And what's great is I can actually go and look at my data set, and you can actually see this comparison of the first experiment, which didn't have that prompt change I made to it, to the new version, which has this friendly eval applied. And I actually get a score on the output from the playground. And what's great is if I go into here, I can actually see why, not only what the label is, but the explanation of the label itself, or the explanation of the eval. So for instance, you see to determine whether the text is friendly or not, it's use of emojis, etc. So when we run evals, LLM as a judge evals, we're not only getting the LLM label itself, we're actually also getting an explanation for why something is friendly or something is robotic, why the LLM as a judge is labeling that output as friendly or robotic. And you can see here it says this is robotic because it doesn't have emojis, it doesn't have a warm tone. So this is the power of LLM as a judge, right? It's acting basically as a labeler for my data, so that when I go back and I change my prompt or make changes to my system, I can verify that those changes are actually making an impact. And that's really what this kind of allows for. Let me go ahead and check. Okay, and we're going to go ahead and close that breakout room so that the folks can join back in. And we're going to keep going ahead with MCP tools and tracing. Any questions on any of this so far on the concept of agents, agent frameworks, evals, any of that so far, or prompt iteration? While we wait 10 more seconds for folks to join.
Why is it necessary to always use evals?
Asking good questions, Biplop. So I'll give you a short answer, and then we have a slightly longer answer in just a moment.
Sure.
The short answer is your evals are basically how you check the output of your system, because LLMs are non-deterministic. In the software world, we have unit tests or integration tests, right? So anytime you push a change, you make sure you're not breaking something. That's the equivalent of what evals are, except they're arguably, you basically need multiple ways to check the output of the LLM, because integration and unit tests always have like a binary pass-fail. Evals are a much more nuanced way to grade the output of LLMs, because they're non-deterministic and because they're subjective, because the outputs of LLMs are often subjective. Evals also don't have to be LLM evals. You can use code-based evaluations as well. And we'll talk more about that as well.
Thank you.
Yeah, good question. And we'll jump into that in just very shortly in about the next 5 minutes. So hopefully by now you've looked at different agent frameworks and architectures, and we hit a couple technical snags, but we're going to keep pushing on here. We're going to talk about what are AI agent tools. And this is just sort of an example of the different types of tools that you can basically give access to your agent. There's data access, which is essentially RAG with things like APIs or databases on top that you can pull from and pull data from. There's extraction, which is think of this as like metadata parsing or pulling data out from a string and doing processing on it. There's execution, which is actually taking action or calling an API. For instance, triggering a workflow or making an API call. And then there's analysis, which is, think of this as parsing logs or doing reasoning on top of data. So these are the 4 very common types of categories of tools. And the reason that you want to apply these tools to your agent is because they can provide, basically think of it this way. When you ask your LLM, what happened yesterday? It's not going to know what happened yesterday because the knowledge cutoff was 6 months ago. So it needs to go and look for recent information. And to go and get that recent information, you basically need to hook it up to a real world API or database. You can also make the agent more specialized by giving it access to these tools, because now it can perform a very specific task like write code or read code. And that means that you can build a system that knows about multiple parts of your, your enterprise or business. On top of that, when you think about, why tools matter in the real world, it's because, LLMs can't directly query databases. Tools give LLMs the ability to basically take action in the real world and bridge the gap between external data sources and what the LLM knows already. So example is like MCP calls, which we're going to hop into now as well. MCP is sort of, it doesn't really, think of it as like, you'll often hear this expression of like MCP is like an API for LLMs. I think that's a pretty good example. It basically is a way for you to give the LLM access to specific actions you might want it to take by describing, in your MCP server, which is Model Context Protocol, you can basically describe the tool, the data, and why the LLM might want to use that tool. And when you think about what your, in your own company, or if you wanted to access other companies' MCPs, it's basically the language that you can use to expose how to take action on your data for external LLMs. It's sort of like here, it's like almost like developer documentation for an LLM is another way to look at it for your API. So the way I would look at it is like MCP doesn't replace tools, it just makes tools interoperable. And it's a standard protocol for you to define essentially these tool calls to make action on your API, on your system. Okay, we're gonna go ahead and skip the MCP sort of demo really quick and actually just hop ahead so that we can get closer to evals in the time that we have. So basically think about it this way: when we'll send out the labs for labs 3 and 4. Fun fact, this is actually just our first sort of run through of the new course that we're launching on our site. So you're all getting like a slight preview into some of the material we're going to have, but we will do a deeper dive into RAG, MCP, and trading off those different approaches for your system. And you can actually A/B test and see which one is going to work best for your system. Okay, with that, we're going to hop into RAG. So how many folks have already, actually quick question for the audience here. How many folks have actually built around MCP or RAG systems in the past? So just so I know how much to cover around RAG. Nice. Sherwood, was it a RAG system or an MCP or both?
It was RAG.
Okay. RAG, yes. MCP, no. Okay. I think RAG has been around a little bit longer, about a year or more than MCP so far from a protocol, but awesome. So we have a couple folks that have built some things with MCP.
So,
yeah, go ahead.
A couple things with MCP, but nothing complex.
Okay. Yeah, I'd say we'll share some more. We'll share that notebook out afterwards, so you can kind of take a first pass at spinning up an MCP server for your agent and using that to see how it works. So when we think about RAG, there's really 4 components here. There's the prompt, which is your user query, or basically going in and generating context that is being sent to the LLM system. But RAG is basically, it's this word that I really think has been subsumed by context engineering. So RAG is basically a way for you to get data from a document store or a database that then you can use as context alongside your prompt template and your user question. And then all of that can basically, all of those retrieved documents that you get from this call to the database is what you send to the LLM system. Part of the reason you want to try to use RAG for a lot of enterprise applications where you have proprietary data that you're querying from in your database, like a file store or a document store, is because it's going to reduce hallucinations, and so that you can run specific checks on the documents that are retrieved to make sure that they're relevant to the question that the user is asking, and so that you can check if the LLM is hallucinating or not based on the retrieved document. So for instance, a hallucination is basically a way for you to check, hey, I retrieved this document from my system. This is the question that the user asked. Is the LLM giving an answer based on the document or just making something up? And you can only really do that if you're checking against a retrieved document. And when you have those retrieved documents, it actually makes the system respond better. Notebook LM is, I don't know if it's actually a good example of RAG. I would probably call it more of context engineering generally, because they're doing a lot of stuff in there. But yeah, actually, you know what? If you copy paste a PDF into Notebook LM, I would say that that is RAG, because it may not be doing RAG like in the sense of like a vector database or chunking or things like that, but it is using the context to respond to the query. So yeah, you could say that. Good question. Arize does have a prompt registry. So I'll show that in sort of in the next slide, but we do have a prompt registry for you to store prompts that you can retrieve from. So when you think about how RAG fits in, how does RAG fit into your agent, right? Well, your AI agent can actually call directly to an LLM, or it can actually make a tool call or MCP call to pull in that retrieve context. So again, this kind of fits in hand with tools and MCP, because basically you can sort of think about, let me actually just go ahead and draft this up really quick as an example. But when we think about our trip planner example over here, we can really think about, like, you know, if I want to go ahead and say I'm planning a trip to Kyoto, you know, Kyoto, this query can actually go and look up from my database information about Kyoto, Tokyo, Osaka. And the RAG system is actually going to go ahead and pull up specifically information about Kyoto. Okay, 1 second here. So it's going to go ahead and actually pull up information specifically about Kyoto. But if I want to access what this database is, I can actually wrap it in a tool call or in an MCP call, and basically have it, you know, actually call this tool call where my database is behind an MCP server. And this is an example of how these three components basically come together to do RAG. Because now I'm retrieving information about Kyoto, and that gets sent to the LLM system. And this is just a really simple example of like how these different components come together. If I ask about Kyoto, it'll make a tool call. This database is behind an MCP server. It'll do a lookup on Kyoto and actually look up that information, send it to an LLM. And that's RAG, essentially. So how does RAG combine with agents? Well, in that example, I just showed like one quick query and then a retrieval from a database. But you can have multiple queries or even adaptive retrieval as well. You can have multiple hops. So I could say, refine my query on Kyoto and tell me about this one specific neighborhood in Kyoto. Or do, you know, further lookups and reasoning on top of the retrieve context as well. So there's a lot of benefits to using RAG when it comes to, you know, taking this data and applying it in your agent system for things like more complex queries, for chaining tools together. And in general, it's just a good fallback for basically having even potentially multiple databases that the agent can query from as well. So the things you want to check for, we kind of talked about hallucination, which is I've retrieved a document. Is my LLM even using it to respond? You can use retrieval relevance, which is this document relevant to the user's question or not? And then, of course, look at the overall correctness and if the LLM is actually citing the document. So there's a lot of things you can actually check to improve the quality of your RAG system and RAG pipeline as well. And these are LLM as a judge metrics that you can run as well. I'm going to skip this one. Okay, we're going to hop straight into evals, and I'm going to run one more eval example, and that will be sort of towards as we get closer to the end of this workshop, and we'll look a little bit ahead. Oh, nice, Sherwood, you've jumped ahead to. I think we might. Okay, we might have to bump your account up one more level to run that notebook.
Yeah, just for the details here. So basically, our engineering team just enforced a policy where you can only have one project per free account. So you just need to use the same project name that we used before. And actually, we're currently reverting this, so this won't be an issue in a few hours.
Awesome. Thanks, Dylan. So, so what are evals and why do they matter? And how does observability, RAG, tool calling, and all of this actually go into evals? Well, we know this to be true. Someone asked us before, why do I need to run evals? The answer is because LLMs hallucinate. Let's actually go ahead and prove that out for a second. So I'm going to go back to my agent trip planner here. And I'm going to say, take me to Hogwarts, right? And we'll see what the agent produces. Well, it gave me an answer, even though Hogwarts isn't a real place. And it's a pretty realistic answer, right? But I can't actually go book a trip here. Now, imagine if this trip planner was public and I had this hooked up to all of my APIs to go and book flights and book trips. Like where, someone has their kid get access to the trip planner, and the kid types in, I want to go to Hogwarts, and you get this really nice itinerary, and the kid's like, great, book me a vacation to Hogwarts. Where is it going to take them? Florida? I have no idea. And the thing is, unless you have evals actually on top of your system, you would have no idea that the LLM is hallucinating, that it's generating answers that aren't specific to your policy. And you don't have to take my word for it. Like, this is literally the CPOs of the companies that are selling you LLMs telling you that evals are important. The OpenAI CPO, Anthropic CPO are saying evals are going to be a really important skill, because if you're deploying this stuff all over your enterprise, you better make sure it's working the way you expect it to. There's a lot of exactly. It might take you right to, Disney. Who knows? Is Hogwarts Disney? Harry Potter? I don't remember. Universal. So, on top of that, I think that there's a lot of conflation around what evals are. So I wanted to try to make this more clear for people here. When people talk about evals, they're usually talking about two types of evals. On the left-hand side, you have model evaluation, which is, think of this as like benchmarks that the foundation model companies are basically using to measure how good their system is. So these are things like SWE-bench, MMLU. You've probably heard of some of these benchmarks in the past. These are actually not super relevant to the types of evals that you will care about with your business. What you would really care about is LLM system evaluation, which is essentially how good is my agent performing for my specific data set of real world data. So this is things like pulling customer data, pulling examples from the trip planner, and building data sets around that, which we kind of ran as an example for some of the folks earlier as well. And just as a reminder, this is kind of what LLM-based applications look like today. You have a user's input query, an LLM, which has all of this nice stuff around it, prompts, tools, data sources, and then an output. A lot of people say evals are just unit tests. Yes and no. on the left-hand side, you have this, think about software testing as like a bullet train or a train going on a track. And really, there's a couple different tests that you can run on this type of system. You can make sure that the train is going from point A to point B correctly, that it's, there's engagement between the train and the track. This is like an integration test. And a unit test would be like, did it get there on time? And if you're on the East Coast, your trains are always going to be late. And so your unit test is probably failing. But, here we are. On the right-hand side, you have something closer to what an agent-based system looks like, which is closer to like a driving test. Because think about driving in a chaotic environment like New York. There's people crossing the street when you least expect them to. There's people, think of that as like someone trying to put in a request like, take me to Hogwarts. Like you can't anticipate everything people are going to do all the time, but your system needs to be robust to those inputs anyway, right? There's no excuse if you didn't stop at a red light, even if someone was like, when you thought you should go. Like, it doesn't matter. At the end of the day, your system needs to be robust to variables. So in unit testing world, you're basically checking how your components work together and making sure each component is tested individually. But in the case of LLMs, you're actually testing end-to-end non-deterministic sort of actions that the LLM can take, because the agent can go off the rails. It can take action on APIs, right? And what you're trying to do is check multiple parts of the system, which is different than traditional software testing. So just to kind of recap that, software testing is deterministic, LLMs are non-deterministic, and we kind of covered some of this earlier. This is really a good slide to kind of pause on for a moment, which is the common types of evaluations for LLM systems. So you have LLM as a judge, which we'll go into more depth on in just a moment. But this is really, LLM as a judge is basically using an LLM to grade the output of your agent or other LLMs. This makes sense because it's sort of like encoding knowledge into an LLM about what it should check. It's sort of like telling a human or an intern, hey, check the outputs here and make sure that they're correct. You have to define what's correct and how to check the outputs. A really common way to test agents and, kind of a less complicated way, I would say, to actually eval the output of the agent is a code-based eval. So this is things like correctness, string checks. For instance, if I'm an airline, like United Airlines, I don't want my customers to come in and ask for me to book their flights on Delta. So I should check the input and make sure that if people ask about Delta, I should say, sorry, I can't help you with that. Like I shouldn't try to help them out. Annotations is basically humans going in and looking at the data. And it's actually, this is where most eval systems start today, is using human annotation and evals. So this is why it's so, you've probably been hearing like there's all these companies that are doing human evaluations and labeling. That's really what annotations are. And then last but not least is business metrics. This is like the thumbs up, thumbs down that you can collect from your end user in the application. It's the human in the loop for your customer support bot. Ultimately, it's the thing that matters most, which is like, is your user frustrated or not? And it's actually the thing that you want to try to encode in your other evals as much as possible and measure as well from your end system when you deploy it. I'm going to focus a little bit more on LLM as a judge metrics. And basically what this is it's using the output of one model to grade another output. So that's basically using an LLM to grade the first agent system. It's really flexible and really great for subjective tasks, which are things like tone, which we kind of used earlier, or quality. As long as you can describe what looks good or doesn't look good, you can encode that in an LLM as a judge. On the other hand, code or rule-based checks are like things like JSON validation. Those are going to be better at deterministic tasks, like where you know that there's like a binary discrete value, like a 1 or a 0. A common LLM as a judge system really contains 3 components. There's the eval prompt, which is what we're writing as a prompt to go into the LLM system. There's the LLM itself that we're using for evaluation. And the things we care about there are cost, performance, latency, and accuracy, just like we would with any other system. And then there's the data that we're actually evaluating. And this is, again, spans, right? This is just a row of data that we're going to put into our LLM system to evaluate in the first place. So input, output, and then maybe a label or expected label that we can use as well. I like to think about the 4 steps for an eval prompt. at the top, you have the role, then you have the context. So the role is basically like telling the LLM, you are an LLM as a judge. Your job is to grade the output of these systems. Then you provide the context, which is the actual variable of like what you want the LLM as a system to grade. You can provide a goal, which is determine whether or not the output is toxic or not toxic. And then last but not least, you define what that means, like what should the LLM output. And you almost always want to constrain the system to respond with a single word, toxic or not toxic, or a label. And the reason for that is because then you can use that label as a classification for other types of evaluation as well. So here, the LLM is always responding with either only of toxic or not toxic. When it comes to designing good evaluations, here's just a couple principles or best practices. You really want to kind of start, I think the most important thing is actually starting with alignment. And this is actually bullet number 4, which is picking the right thing to measure and making sure it's aligned with your human evaluations in the first place. Once you've kind of started doing this error analysis of different modes of failures, so you can start finding, okay, here's where my LLM isn't performing well. Is it the tone? Is it the quality of the output in some way? Is it correct or not? Is it the RAG or retrieval? Then you can go in and sort of further segment, okay, how do we measure this part of our system? It's the same as humans looking at data and seeing like, is this good or bad or not? And yeah, just to put it all together, you really need observability at the top level to be able to even run evals in the first place. And once you have a system that's actually, you have observability with traces, you're labeling with evals, you can actually build a feedback loop on top of your agent system using this data as well. And I'm going to go ahead and show a live example of this, and this will work with your trip planner that you just set up as well in the Arize application. So you can measure a couple of things here. We started with tone. You can also look at tool calling and overall correctness. So what I'll do is, in case you were in the breakout room, you can actually just copy paste this prompt, and I'll just copy and paste it back in again. And let's just go ahead and run this together. So I'm going to go back to Arize, and let's go ahead and just run this example one more time for folks, in case people missed it. Oh, logged out. There you go. That's correct, Sherwood. You will. So what you can do is go to the itinerary, and let's go ahead and delete these. And create a new experiment. We'll load in the prompt that we just saved. And we're going to do an A/B test here. I'm going to say always respond in a friendly way and use emojis. So now I'm requiring something from my LLM to do. I can also change the model and say GPT 4.1. And I can set up an eval, which I already have here because I copy pasted it before. But if you haven't, you can just hit add eval and define that eval prompt. What you're actually going to do after you do this is actually compare it to human labels as well. So let's go ahead and run that in here. And really just with a couple clicks, I can do this A/B test and see what the output of my system looks like. So feel free to follow along if you have been putting examples into your trip planner and want to run an eval live. Wow. Okay, it's so much better. It says, absolutely. I'd love to help you plan 5 unforgettable days in New York. Maybe it's a little over the top, honestly. We might want to adjust that later down the line too. And I can go in here and you can see, great. Okay, it's actually grading the first, the data set of rows initially with 0 versus when I make that adjustment to the prompt, it's actually getting better and it says it's more friendly based on the eval that I just defined. I could also go in and label that data myself and actually provide human labels on top of the data set. So I could say, I want to actually label the data in this in the Arize platform and label it either, so 0 is robotic, and then this is friendly. And say friendly. Select the data set and add in my annotation. Awesome. So let's go ahead and label this now. So I can actually label the outputs that I'm looking at with either robotic or friendly. So this is some of the original outputs that I can compare to. I think these ones were not super strong, so I'm going to go ahead and label them as robotic. And then what I can do is actually compare. What's great about when I just label that data here is it actually applies it back to the same data set. So I actually now have this column on my data set, which were the labels that I just provided, which is great because it means I'm not actually copying any data. It's just the same data set, except I'm labeling data in the same platform. And I can use that label data to actually run another experiment. And let's go ahead and copy a quick eval here. Actually, we'll just run this one live. See if this works. Actually, we want to look at the eval. This one may or may not actually have been done. Well, what you could do is actually compare the match rate of the LLM eval to the human label as well. So you can actually look at the two columns side by side and see, is my LLM eval matching my human annotation or not? So just kind of show that really quick. And we'll just do like a quick comparison here. Eval friendly label. Nope. I think we have a slight bug in the system, not pulling those columns. No worries. Okay, and let's go ahead and push ahead here a little bit more. So once we've actually run those human labels on here, someone asked a good question earlier of, does Arize have a prompt hub? And we do actually. You can save an example prompt or update the prompt as well. So I could make changes to it and actually save it back to the initial system. And from here, I can actually pull down the prompt if I want to use it in my code as well. Okay, we're going to go ahead and push ahead for the last little bit here, talking about how to use evals to actually deploy your agents into production. Yeah, you can actually share WID. You can actually capture your OTel metrics and logs and store them in Arize. We're just an OTel collector as well. Good question. So the thing is that, like, even after you have your LLM, system hooked up to, agent system hooked up to traces, you're running evals. The thing is, you actually need ways to measure the quality of your agent over time. And so you actually need monitoring and dashboards to come back to and look at how your agent is performing over time. A lot of systems will tell you can look at cost and latency to measure if your agent is doing well. I think you're going to run into issues if you're not actually tracking eval metrics over time through monitors as well. Think about it this way. you've now inserted a dependency in your product through an external API call. What happens if OpenAI goes down, or they change the model on you, or they're, decide to use a different model tomorrow and you have no idea? That's really what you need. Honestly, a very common problem here is the underlying model shifting in some way. And so that's why you really need monitoring and sort of security and compliance checks for people trying to jailbreak your system when you didn't even realize that there was a vulnerability in the first place. So of course we have cost tracking in the platform as well. So you can actually monitor using costs. We also have monitoring for some of the sort of main services out there, like PagerDuty, Slack. You can get an email notification if your thresholds are above a certain value. And I'll kind of show what that looks like just for us to have as a reference point. But you can actually set up monitors here on qualities like evals as well. So I could say, for my generative tracing, I want to go ahead and measure my evals and look at my hallucination score. And you can see that this is an example of a monitor that's set up on my system for the eval that I set up, which is hallucination score. So all of those evals I was running earlier, you can have them actually running on all of your incoming data and actually have monitors set up on evals for your incoming data too. So if you go into here, you can actually set up evals as jobs or as tasks on all incoming data as well. And that's what the monitoring kind of looks like in the Arize system as well. Gonna skip red teaming because it's less relevant. I'm gonna throw one more kind of best practice your all's way as you think about agents, which is think about guardrails. It's another way to look at this as like real-time evals. We actually integrate with some of the leading guardrail providers out there, open source ones like Arize AI or Nemo guardrails. And what's really interesting about this is you can actually build guardrails that are specific to your failure modes. So guardrails are like blockers in real time to make sure that the LLM doesn't produce some text that's garbage or, not actually what you want the system to generate. Okay, so just a quick recap here for this workshop. We've kind of covered a lot of ground. You should have got an agent set up on your machine. We've gone through and actually run the agent and hooked it up to observability and done some agent engineering on the prompt or iterated on the prompt. We've explored different frameworks and architectures for agents. Instead of just TypeScript and Python, we've actually looked at all of the different major frameworks out there. We've talked about tools and MCP and how planning and reasoning and APIs all impact the quality and output of your agent in the first place. We talked about RAG and being able to change your documents or change your, your RAG strategy to actually update what your LLM produces. And then we've hooked that all up to observability and evals so that you can run evals on your A/B tests when you're running an A/B test on a prompt or an agent system or changing your model. But you can also have those evals run on all of your data coming in when you think about production as well. So we've covered a lot of ground. The interesting and sort of the good news here is there's actually more. You can actually do things like advanced agent evals on trajectory, convergence, parameter extraction, and planning. I'll show an example of one of these just to have, just for us to take a look at really quick. But you can actually run evals at a much higher level, at a higher level than just spans. You can actually run them on multiple spans as well. And we call these agent evals. And this is actually a new and emerging area of evaluation that we're actually helping lead and sort of build research around. So you can actually check if your agent is performing well at the highest level, not just individual parts of your agent. So I highly recommend you check this out. We'll drop a link to this for you all to access later as well. But let me just go ahead and put this in the doc so that you have access to it now too. When non-RAG generative AI applications, which evals work, JSON inputs. Yeah, so you can basically the evals that are even non-RAG evals will work just fine on individual spans. It's all about taking the input output JSON and running evaluations on that. And if you like this and you want more and you want to get deeper into best practices on building agents, you want access to more notebooks, you want access to support like Dylan and myself, I highly encourage you to scan the QR code to join our Slack community for both Arize and for Phoenix, which is our open source community. Please give us a star on GitHub if you're in GitHub as well. And would love to have your support as we build this out. It's an open source project. We really appreciate all of your support. And feel free to stay in touch. Reach out to me on X or LinkedIn. I'm happy to help as you get further in your journey. But thank you so much for joining and for spending this almost 3 hours together. I really enjoyed it. I love live debugging. I actually love when things go wrong because this just helps us get better and learn. So hopefully this was fun for you all too. And thank you for spending the time. And thank you for Data Science Dojo for having us. I'll stick around for 5 more minutes for any questions people have.
Yeah. If you have any questions, please feel free to ask Aman and Dylan, and then we'll be closing the workshop. But you have time. You have 8 minutes right now.
Dylan, I think there was a question on the link to the Slack community.
Yeah. Can you share the link in chat or maybe the QR code?
I'll go back here as well so people have it.
Perfect.
Yeah, the QR code didn't work.
Thank you. That's pretty good to know.
So I don't actually know about either of those platforms, Pushbox. I've used NNN a little bit, but I'm probably not the right person to ask about those.
I can answer for that. Like
Sure.
for prototyping, to have like a proof of concept, you want to create your business, you want a proof of concept that to showcase it to investors. NA8 and make.com are probably like the best options, but those are not systems that can scale or that can be like extremely reliable. It's like you get to a point of like a working demo like very, very fast with those systems, but then you hit a wall that is like impossible to to get above. So yeah.
One question I do have. So our organizations are very strict about the data. So all we can experiment is with the self-hosted ones. But I do see that self-hosted ones have restrictions. I can't try the optimizer framework and stuff like that. So how do we experiment? Do we get a trial period for self-hosted and I can play around?
Yeah, I don't know much about. Wait, sorry. Sorry. Maybe I misunderstood the question. Was this for Arize or Phoenix, Shri?
Means the tracing tool you showed, the Arize.
Okay.
So I want to explain that.
So your question was around self-hosting. Is that the question?
Yes, it was around self-hosting.
So we provide VPC deployments. Those are paid POCs that we run for enterprise sort of applications or use cases. And then we have Phoenix, which is the tool we didn't go into too much depth on, but it's very similar to Arize. I just dropped a link to it, and you can self-host Phoenix in your own environment. And it's fully open source. You don't even have to talk to us about that.
Phoenix is the open source equivalent of Arize. So both platforms are very similar.
Okay, so it has all the optimizer and the good to be features, whichever I saw would be also available, I assume.
It's probably worth trying out Phoenix and kind of coming to your own conclusion, I would say, because there's going to be differences between the two. Obviously, one is open source and the other one is a fully fledged enterprise platform. Here's an example of what I mean. Arize has monitoring, dashboards, evals, that you can, evals in the platform. Phoenix will have evals as well, but it doesn't today yet. And Arize has the co-pilot that you saw, the agent that you saw in the platform as well. I don't know if you saw that one, but we had an agent in the platform. Kind of show that really quick as well. And so if you want access to all of those, that will actually require you using Arize, because that's not available in Phoenix.
Okay.
Yeah.
Is Arize, I can buy it as self-hosted version? Can I buy it for my organization?
I would say yes, is the short answer, of course. I mean, we're here to help you out. I would recommend reaching out to us to book a demo, and we can discuss any specific questions you have around that with that call.
Makes sense.
Yeah, but absolutely. We work with some of the leading enterprises here. I just went ahead and updated our website recently. So you actually see some of our cool new logos as well.
Makes sense, yeah.
Yeah,
It was a very
thanks.
good session, loved it.
Thank you. I'm so glad to hear that. And feel free to ask us any questions you have as you get started with Arize too. And this is what the co-pilot looks like.
Okay.
Thank
This
you.
is the interesting feature, so it's nice.
Yeah, this one's an Arize only feature. It can help you write evals. It can help you iterate on your platform as well from here. And we're going to expose it as an MCP as well.
Not it.
Great. Okay, I think that might be it. Thank you all again, and stay in touch.
Perfect.
Thank you very
Thank you
much.
so much, Dylan. And thank you so much, Ahmad, for such a composed workshop. and
Last
so
question,
smooth.
where you get a PowerPoint for this session? Is it come with a video or?
I'll give that one to our Data Science Dojo friends. Are you sharing the videos after this?
Oh,
We'll
the
be sharing the
PowerPoint,
whole
not the only
PowerPoint.
the
Yeah,
video.
yeah. We'll be sharing the slides as well.
Should I just drop
okay.
a link to them in the chat?
Yeah,
Would
yeah.
that be helpful?
I'll ask you over email. That's fine. We'll communicate over email. That's okay. And thank you so much, everyone, for joining. Thank you, Ahmad.
Thank you.
And
A very helpful, very detailed training. Thank you.
Perfect.
Thank you.
Bye-bye. Thanks, everyone.
Thank you.